Types of normal forms. First normal form 1NF. In first normal form, table cells must be of single values. So eliminate the repeating groups in each table. Create a separate table for each set of related data. Identify each set of related data with a primary key. Consider this product table, which is not in first NF because the column color contain multiple values, such as second and fifth row has multiple values. Primary key. To bring this table to first normal form, we can split the table into two tables with primary key as reference. Primary key. Now the first normal form is satisfied as the columns of each table, product price and product color, hold just one value. Second normal form 2NF. Tables are said to be second normal form when the table meet the criteria, that is criteria. Cell must contain single value for first normal form. All non-key attributes must depend on every part of the primary key. Non-key attributes are the attributes that are not a part of the key. For example, birth date is a non-key attribute because many people could have the same birth date, so birth date column would not be a key attribute for a person table. It would be a non-key attribute of a person table. Consider the following purchase detail table. Primary key. Non-key attribute. This table has a composite primary key, customer ID, store ID. The non-key attribute is purchase location. In this case, purchase location only depends on store ID, which is only part of the primary key. Therefore, this table does not satisfy second normal form. To bring this table to second normal form, we break the table into two tables and now we have the resultant tables such as table purchase and table store. In the table store, the column purchase location is fully dependent on the primary key of the table, which is store ID, as shown in the figure above. Third normal form 3NF. Tables are said to be third normal form when the table satisfies the criteria, that is condition for second normal form. All non-key attributes should depend on the primary key. There is no transitive functional dependency. Transitive functional dependency means table A is fully functional dependent on B and B is functionally dependent on C. In this case, C is transitively dependent on A via B. Here, A, B and C are columns. Consider the following example. Primary key. In the table, book ID determines journal ID and the journal ID determines journal type. Therefore, book ID determines journal type via journal ID, and we have a transitive functional dependency, and this structure does not satisfy third normal form. To bring this table to third normal form, split the table into two as shown in the figure above. Now, all non-key attributes are fully functional dependent only on the primary key. In table book, both journal ID and price are only dependent on book ID, and also price depends on journal ID. In table journal, Journal type is only dependent on journal ID. Boyce Codd normal form or fourth normal form. A table is in Boyce Codd normal form BCNF if it satisfies the condition of 3NF and every determinant is a candidate key. Determinant in a database table is any attribute that the user can use to determine the values assigned to other attributes in the same row. For example, employee table has columns such as employee ID, first name, last name, and date of birth. In this case, the employee ID column determines the remaining 3 fields. A candidate key is a column or set of columns in a table that can uniquely identify any database records without referring to any other data. This can be expressed as R of A, B, C, C to A, where the relation R contains attributes A, B, and C. A and B form a candidate key. C is the determinant for A. A is functionally dependent on C. C is not part of any key. Anomalies, that is duplicate data or repeated data, can also occur where a relation contains several candidate keys where the keys contain more than one attribute. They are composite keys. An attribute is common to more than one key. Consider this example. Campus table, which is not in BCNF because no 2 buildings on any of the university campuses have the same name. Thus, room or building to campus, as the determinant is not a candidate key. This table should be decomposed into 2, a table in which table 1 contains columns such as course, class, time, and room or building. Table 2 contains columns such as campus and room or building, thus satisfies BCNF conditions. Fifth normal form. An entity is in fifth normal form 5NF if and only if it is in the fourth normal form and every joint dependency for the entity is a consequence of its candidate keys. In this example, namely one involving agents, companies, and products. If agents represent companies, companies make products, and agents sell products, then we might want to keep a record of which agent sells which product for which company. This information could be kept in one record type with 3 fields. For example, although agent Smith sells cars made by Ford and trucks made by GM, he does not sell Ford trucks or GM cars. Thus, we need the combination of 3 fields to know which combinations are valid and which are not. But suppose that a certain rule was in effect. If an agent sells a certain product and he represents a company making that product, then he sells that product for that company. In this case, it turns out that we can reconstruct all the true facts from a normalized form consisting of 3 separate record types, each containing 2 fields. These 3 record types are in fifth normal form.